All right, friends, we are going to take a look at what happens when you are trying to solve by factoring a trinomial and the number in front is not a 1, because in the previous lesson, every single one of these started with 1x squared, not 2x squared or any other number. Now, I actually probably do this a little differently than your other teacher, and so if this is a confusing method, you can look at the filled-in notes that your teacher posted and you might recognize like the snowflake method or crisscross, whatever you call it. Here is what I do. When I notice that there's a number in front, which is this guy, for now, temporarily, I write 2x here and here. That's kind of cheating, so later on I'm going to have to divide that out. Then I multiply the first and last number. I don't care about positive or negative, just 2 times 3. Then I do exactly what I did on the first worksheet. I split that up using my blue card. I see that 1 and 6 or 2 times 3 are my options on the blue card. But then, just like yesterday, they need to subtract to be 5. 2 and 3 do not subtract to be 5. They add to be 5. So 1 and 6 are my options. And just like yesterday, to get a positive 5, I would need a positive 6 minus 1. Here's the catch. Because I sort of fake inflated that first number 2x, because in real life, if I FOILed this, 2x times 2x would be 4x squared, not 2x squared, and that's too big. But at this point, I reduce. This does not reduce by anything, but see here, I can divide a 2 out of this one. 2x divided by 2 is x, 6 divided by 2 is 3. Those, my friend, are my factors. So I'm kind of inflating it to work on it and then deflating it to give me my final answers. To find my zeros, I set each one of those equal to 0, just like yesterday. And I either stare at it or I do math to figure out what's going to make that factor equal 0. And those are my zeros, my x-intercepts, and the places where that parabola would cross the x-axis. Here, let's try it again. I see it has a number in the front, so I put that number here and here for now. Multiply the first and last. I look at my card. I have 1 and 12, 2 and 6, 3 and 4, but I need them to subtract to be 11. So the only option is a 1 and a 12. In order to have a positive 11, I need a positive 12 minus 1. Then I reduce one or both. This one can divide out by 4, giving me x plus 3. But this one, 4x minus 1, you can't divide anything out, so you're stuck with it. So those are my factors. I like that method because it doesn't leave me with any guess and check. Now to get this one to equal 0, I'll just need a negative 3. And to get this one to equal 0, I'll need a 1/4. All right, let's keep trying. So I see that number in front. I write it for now here and here. Then I multiply. Well, 6 times 1 is still 6, so my choices are 1 and 6, 2 and 3. I need it to subtract to be 1x. So the only ones that'll subtract to be 1 are a 3 and a 2. I need a positive 1, so positive 3 minus 2. Now in this case, they actually both reduce. This divides by 2, this divides by 3. So this turns into 3x minus 1 when I divide it all by 2, and this turns into 2x plus 1. So those are my factors. What I get after I reduce are my factors. Then to make this equal 0, I'll need this to equal 1, and dividing puts me at 1/3 as my first 0. To get this equal to 0, I'll need to move the 1 by subtracting, get rid of the 2 by dividing, and negative 1/2 is my other 0. All right, same thing. I notice there's a number in front. I'm going to do my same approach. I see that it's a 2, so for now I'll put it here and here. These two become a 4. So on my chart, I see 1 and 4 and 2 and 2 as options. I need them to add up to be 5. So I'm picking 1 and 4. To get a positive 5, I'll need a positive 1 plus 4 more. In this problem, this is the only one that will reduce. So I end up with 2x plus 1, and dividing each of these by 2, I just get x plus 2 left over. To figure out what makes them equal 0, I set them equal to 0 and I start mathing and I end up with negative 1/2. Here to get x plus 2 to be 0, I would simply need to use a negative 2. All right, I see that this one is starting with a 4. So I put 4x here and here for now. 4 times 15 is 60. Whoa. So I have a lot of options. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and hopefully I didn't forget any, but I need them to subtract to be 4. So my last option is the best option. To get a negative 4, I'll need negative 10 plus 6. Now this one reduces by 2, and so does that one. So if I divide the first one in half and divide the second one in half, that lands me on the proper factors. Then I'm going to set each one equal to 0 and do algebra 1 to figure out that 5/2 is one of my zeros. And over here, negative 3/2 is my other 0. All right, I see a 10, no big deal. I'm gonna write it here and here for now. These make 60. I'm gonna actually cheat and look back here because I had the same number before, but now I need them to subtract to be 11. So I look back and 4 and 15 are on my list. That makes 60, but they also subtract to be 11. To get a positive 11, I'll need positive 15 minus 4. Then this divides by 5, and these divide by 2. So if I divide this by 5, I'll have 2x plus 3. If I divide the second one in half, I'll have 5x minus 2. So those reduced versions are my final factors. And then my zeros are whatever makes this equal 0 and whatever makes this, oops, I'm gonna just go ahead and set that equal to 0. So I'm adding the 2 over. Hope that's okay. And then dividing by 5. So my zeros will occur at negative 3/2 and at 2/5. Those are the two places it'll cross the x-axis. All right, so I already know kind of how these set up. You made a rectangular quilt. All right, there we go. That's not very good. But 5 by 4. All right, you want to use the remaining 10 square feet. Well, keep in mind this is 20 square feet because area is base times height. So for me, that's going to be 5 times 4, or length times width, however you want to think about it. So the area I have is 20. If there's 10 left over, then keep in mind I have 30 as my total amount of fabric. Because you're going to add a decorative border to the quilt. So all the way around, I'm adding a border of uniform width, meaning the same. So whatever this is, that's how big this is. Like every corner, I'm adding X. So they want me to find the new width. Since this is the shorter one, that's probably the new width, the width, but they want to know what it's going to be like here. So think about it. I used to have 4, but I added that border that's X here and here. So this becomes 2 X's plus the 4 that I had. Likewise, this was a 5, but I added an X to each end. So this length becomes 2 X's plus the 5 I already had. So the 2x plus 4, meaning the new longer side, and the 2x plus 5, meaning the new longer bottom, those have to total up to 30, which is all the fabric I have. So just like yesterday, I need to FOIL and then factor and set it equal to 0. So this is going to be 4x squared plus 10x plus 8x plus 20. That's just FOIL. Now I can write it all together. These are alike. And then I'm going to move the 30 over because I need it equal to 0. So I'm going to have negative 10 equals 0. And the reason this is in today's homework is this has a 4 in front. So I'm going to have a 4x here and here for now. 4 and 10 is 40. So when I look at my blue sheet, I have 1 and 40, 2 and 20, 4 and 10, 5 and 8. But according to this, I need them to subtract to be 8. Oh, I'm sorry, I need them to subtract to be 18. I was like super stuck. So 2 and 20 works. I need it to be a positive 18, so positive 20 minus 2 will give me that.
There's stuff on the other side, we're gonna move it. And then we're gonna factor it. So this business